Welcome to another science exploration. Today, we are going to explore about which planets are the ice giants of the solar system, how are they formed, and what would happen if you tried to land on these planets. Okay, so let's dive right into this. We're talking about Uranus and Neptune today. These are two absolutely massive, super mysterious worlds hanging out at the very edges of our solar neighborhood. Have you ever wondered what it would actually feel like to fly a spaceship all the way out there, open the door, and try to step out onto their surface? Well, you better buckle up, because the journey is going to be wildly different from anything we experience right here on Earth.
Now, I'm going to let you in on a little secret. The name ice giants is actually a bit of a trick. I know, right? When we hear the word ice, we naturally picture these huge frozen snowballs, or maybe giant ice cubes floating in space. But that couldn't be farther from the truth. Scientists just use the word ice to talk about specific materials that were frozen way back when the solar system was just starting out. But deep inside Uranus and Neptune today, those materials aren't frozen solid at all. Because of the enormous pressure and super high temperatures, they behave way more like superheated liquids. It's kind of like a thick, dense slush. Imagine trying to land in a giant bowl of boiling hot, thick soup instead of on a snowy winter day.
To understand why they're like this, we actually have to travel back about 4.6 billion years ago. Back then, our solar system was just this giant, swirling cloud of gas and dust. Near the sun, it was super hot, so only hard stuff like rock and metal could stay solid. But way out in the freezing cold outer regions, things like water, ammonia, and methane froze into ice. Uranus and Neptune grew up out there in the cold, basically scooping up massive amounts of these icy materials. They also grabbed a little bit of hydrogen and helium gas, but, not nearly as much as the bigger planets like Jupiter or Saturn did. So that specific cosmic recipe, lots of icy materials and a little less gas, is exactly what makes an ice giant.
So that brings us to the million-dollar question. Can we actually land on one of these things? Let's take a look at Uranus first. It holds the record as the absolute coldest planet in our entire solar system. The temperatures at the very tops of its clouds drop to an incredible -224 degrees Celsius. That is unimaginably freezing. So if we fly our state-of-the-art spaceship all the way to this frozen world, can we find a nice flat spot to park and step outside?
The short answer is nope, not a chance. And this perfectly shows why these planets are so mind-boggling. Uranus has absolutely no solid surface. None. Zero. If you tried to land, there is literally nowhere to put your feet. You would just keep sinking forever. And take a look at the planet's striking blue-green color. That beautiful hue? It's actually a trick of the light. The atmosphere is just completely full of methane gas. That methane absorbs red light from the sun and reflects blue-green light right back to our eyes. So it looks like a super peaceful blue marble, but trying to land there would be a huge mistake.
But let's just imagine for a second you completely ignore my warnings and you decide to parachute into Uranus anyway. What exactly would happen to you? Well, in stage 1, up in the upper atmosphere, it actually wouldn't look too bad at first. You'd drift through these pale blue-green clouds and faint cloud bands. It would definitely look a lot different from Earth's sky, but it would seem relatively calm. However, as you sink lower down into stage 2, things start to get pretty scary. The pressure begins to rise really rapidly, and the temperature starts getting super hot. Those calm gas clouds you were just in, they become thicker and denser, slowly changing from a regular gas into this crushing, heavy, fluid-like layer.
And trust me, the drop doesn't stop there. Plunging deeper into stage 3, you'd slam right into the superheated ice layer. Remember that boiling hot soup we talked about earlier? Well, here it is. This huge layer is made of water, ammonia, and methane, all compressed into an extremely hot, dense fluid reaching thousands of degrees Celsius. Finally, in stage 4, assuming your spaceship hasn't been completely melted and crushed by now, you'd smack right into the core. Right at the very center of Uranus is a ball of rock and metal. The pressure down here is millions of times greater than on Earth. Oh, and one more really crazy thing down there, scientists actually believe Uranus has a bizarre magnetic field that is completely tilted and pushed way off to the side of the planet. How weird is that?
Okay, so Uranus is a definite no-go for a landing. But what about its neighbor? Let's shift our mission over to Neptune, the farthest major planet from the Sun. It sits even deeper into the freezing, totally dark outer solar system. So, does the farthest ice giant offer us a solid place to touch down?
Spoiler alert, the answer is no again. Just like Uranus, Neptune has absolutely no solid surface for us to stand on. But falling into Neptune, that is a very different, much more violent ride. Even though it's super far from the sun and an incredibly chilly -214 degrees Celsius at the top of the clouds, Neptune actually produces its very own internal heat. Because of this, stage 1 of your fall would be totally wild. Instead of those calm skies we saw in Uranus, you'd be plunging through deep blue clouds, flying right past bright white storms in these massive dark storm systems. Neptune's atmosphere is incredibly active and chaotic. Now get ready for the sheer raw power of Neptune. As you sink into stage 2 of your fall, you would run smack into the fastest winds in the entire solar system. How fast are we talking? Try over 2,000 kilometers per hour. That is actually faster than the speed of sound right here on Earth. Just think about that for a second. The winds on Neptune are moving faster than a supersonic fighter jet. Any spaceship trying to float down through this layer would be instantly tossed around and absolutely crushed by the raw power of the wind alone.
Now, if you somehow magically survive those supersonic winds, you'd sink down into stage 3, the superheated interior. Just like on Uranus, the temperatures down here rise super rapidly, and the pressure increases enormously as you swim through this dense, hot, fluid-like mix of water, ammonia, and methane. Eventually, you keep sinking into stage 4, the deed mantle, and finally, stage 5, hitting the dense rocky core at the very center of the planet, which is completely surrounded by all those superheated materials.
But you guys, here is absolutely the coolest, most magical secret hiding deep inside Neptune's mantle. Under the immense, truly unimaginable pressure found deep inside the planet, something almost like magic happens. The intense pressure actually squeezes the carbon atoms right out of the methane molecules. It squeezes them so hard and so incredibly tight that they actually turn into tiny diamonds. Scientists really believe that deep inside Neptune there is literally a diamond rain falling slowly down through that hot, dense fluid toward the core. Just imagine that for a second. A planet where diamonds fall out of the sky like raindrops.
So, to wrap up our incredible journey today, we learned that the ice giants aren't just boring frozen snowballs floating out there in the dark. Not at all. They are these extreme, wildly swirling worlds made of superheated slush, hiding supersonic winds, crushing rocky cores, and even magical showers of diamonds. We could never ever step foot on them, but they are absolutely some of the most fascinating planets in our entire universe. And it really makes you wonder, if it rains diamonds on Neptune, what other bizarre, completely unimaginable weather is hiding out there on planets far outside our solar system? If you find the video informative, please like the video. Thanks.